Hi everyone, let's solve this problem, rotting oranges. You are given an m cross n grid where each cell can have one of the three values, 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until a no cell has a fresh orange. If this is impossible, return -1. So let's try to work on this particular problem. First, initially, let's also have a time variable to understand how many minutes it took for us to rot all the oranges. So at time 0, this orange is already rotten. Okay, before that, let's also understand the terminology they have given. 0 is empty, 1 is a fresh orange, and 2 is a rotten orange. And they also have given that any cell can be traversed in 4 direction. Considering this as r comma c, it would be r minus 1 comma c, r plus 1 comma c, r comma c plus 1, and r comma c minus 1. And if we are taking it as 0 comma 0, it would be minus 1 comma 0, it would be plus 1 comma 0, and it would be 0 comma minus 1, and it would be 0 comma plus 1. So these are all the possible directions which any cell can be traversed. Now at time 0, this orange is rotten. At time 1, I can go in these two directions. So these two oranges are rotten, and because of this orange, these two oranges also get rotten at time 2. And at time 3, because of this orange gets rotten. So done. And because of this orange gets rotten at time 4. So the time is 4, and that is how we get the answer. Now let's take another example. Let's say I have a grid of 3 cross 3. In this case, it's rotten, fresh, empty, fresh, and fresh. So this is how the grid looks like in this case. Now, along with the time, I will also maintain number of fresh oranges. You will understand why am I maintaining that. So total number of fresh oranges are 1, 2, 3, 4, 5, 6. So I have maintained it, and this orange is already rotten. So now we are going to start. At time 1, this orange gets rotten, and because of this orange and this orange gets rotten at time 2. Okay, I also have to reduce the fresh oranges to 3, and because of this orange also gets rotten at time 3, and this orange gets rotten because of this orange at time 4. And now the number of fresh oranges are 1. So if you see, this orange is never reached or never rotten. So in this case, we have to maintain the number of fresh oranges, because if number of fresh oranges is equals to 0, then we will return time. Otherwise, we'll return -1. So this is the logic which we need to do. So now we are going to use a breadth first search for this. So we are going to again understand how we are going to use the queue for the same. So let me take the initial oranges state which we have. So these are 0, 1, 2, 0, 1, 2, and initially we had rotten orange, and then we had fresh oranges in these places. So I just copied this in terms of like rotten and fresh oranges. And now let's also have a time. Let's have fresh count. This has fresh count as 6, and we will maintain a queue because we are using a breadth first search. This will be the queue, and we will initially push the rotten, and for queue we will also get the length, and we will process all the elements until the length is 0. So this element is rotten already. We will pop this element 0, 0. This is already popped, and now since it is already popped, we have to push 0, 1 and 1, 0. And now we have already pushed the elements, and now the length will be 2 and the time will be still it will be 0 because we haven't processed any of the elements, right? So no, while we are pushing, we will also rot this elements. So at time 1 we have rotten these two elements, and then the length is 2. Now we will pop this element 0, 1. When we pop 0, 1, we will push. When we pop, the length will be 1 now. We will push 0, 2 and 1, 1. But we are not going to change the length because we took the length before pushing them. So it will be length 1. And now again this element will be popped and the length will become 0. So when we pop 1, 0, we will also push 1, 1, which we have already done, and which we are going to mark these two as rotten. So now the number of fresh elements are 2, and at time 2 units we have rotten all these fresh oranges, 4 fresh oranges. And now again we will take the length of the queue. So length of the queue now again is 2, and we can also get of these two elements to avoid the confusion. Now we have these two elements, and again we will do the same process. We will pop 0, 2 and we'll reduce the length of it as 1. And for 0, 2 there are no adjacent oranges which are fresh, so we will not push into our queue. And then we will decrement our length by popping 1, 1. Once we pop 1, 1, we have 2, 1, which we will map it as rotten, and we will push it into our 2, 1 into our queue. So now the time is 3. We have processed 3 minutes so far, and now we have 2, 1. Now again we will calculate our length to 1 because the length of the queue is 1, and we will pop it. Once we pop it, we will insert 2, 2. We will insert 2, 2 and we will mark it as 0, and fresh will number of fresh oranges will be 0, and we have processed 4 units so far. And now the length is 1. We still have 2, 2, but we don't have to traverse this elements in the queue because this particular element has no value because we have already processed all our fresh oranges and we got the time. So this is how we are going to solve it. Now let's try to code this up. So let fresh is equals to 0, let time is equals to 0 as well, and let queue is equals to an array. So now let's for let I is or r equals to 0, r less than grid dot length r plus plus. For let c is equals to 0, c less than grid of 0 dot length c plus plus. In this case, if grid of r comma c is equal to 1, then we will increment our fresh oranges count. And also if it is a rotten orange, we have to push it into our queue. So how do we know if it is a rotten one? If it is equal to 2, then we will push into R comma C queue. Then once we get this, we will, while queue dot length is greater than 0 and fresh is greater than 0, so both of the conditions should match. That's when we are going to iterate over all of this. And also let's maintain our directions. This is nothing but which we discussed, 1 comma 0 minus 1 comma 0, 0 comma 1, 0 comma minus 1. So these are nothing but the possible directions which we discuss at this position. So this is done, and at this point we will also calculate the length. Since we are calculating the length here at this position, it will be constant even if we push the rotten oranges into our queue. And when we get the length for let I is equals to 0, I less than length I plus plus, we will first pop the element from the queue. So let current row comma current column will be queue dot shift, whatever we have popped, or so we are popping it from the front, that's the reason we are using shift. And then once we get it, we have to ensure for let dr comma dc of directions. So we have to ensure that all of these directions are taken care. So in this case, what will we do? Row will be cr plus dr, and let column will be cc plus dc, right? And once we get this, what will we do? We will mark grid of, okay, before marking we also have to do one more thing. If row is less than 0 or row is triple equals to grid dot length, or column is less than 0 or column is equals to grid of 0 dot length, or grid of row comma column is not equal to 1. That means we just have to continue our process, because they are either out of bounds or it's not a fresh orange, so we don't really have to process it. Otherwise we will have to grid of row comma column. Okay, let me also bring, yeah, we will have to mark it as rotten, and then we have to push into our queue, and we have to reduce our fresh count by 1. Once this entire process happens, we have to increment our time, right? And towards the end, if fresh is equals to 0, then we will return time. If not, we will return -1. This is how it should be. Now let's try to run it up. Okay, it's accepted. Let's try to understand the time and space complexity of this solution. So time complexity is nothing but m cross n, which we are doing in this entire loop, and we are iterating inside the queue like this while loop is iterating over all the elements in the grid, that is nothing but m cross n. At max queue can have m cross n elements in it because we are pushing every cell at max once. And then once this is done, this for loop will just take as big O of 4 constant time, so we are not going to consider this time. So it would be big O of m cross n, and the space complexity of this would be m cross n because we are using a queue for maintaining the row comma column positions in our queue. So this is how it works. I hope the solution is clear. Thank you.